Hello everyone, welcome back to my channel. So in today's video, I'll be talking about AWS Solution Architect Associate practice exam questions. So these are the practice exam question and answers which you can practice before going for this particular Solution Architect Associate exam. I would recommend you to practice these questions. So I have created a series part 1 and part 2 which you can go and watch. I'll leave the link in the description box, and now we will start with part 3 of this particular series. So let's look into the questions. So question number 31, it says a company that hosts its web application on AWS wants to ensure all Amazon EC2 instances, RDS-DB instances, and Redshift clusters are configured with tags. The company wants to minimize the effort of configuring and operating this check. What should a solution architect do to accomplish this particular task? So basically, these different components or different services in AWS are configured with tags, and company wants to make sure with the minimum effort that these are being configured, and they are being configured with the correct tags. So how should solution architect go about in order to solve this particular problem? So the options are: A, use AWS config rules to define and detect resources that are not properly configured. Option B, use cost explorer to display resources that are not properly tag those resources manually. Option C, write API calls to check all resources for proper tag allocation. Periodically run the code on an EC2 instance. Option D, write API calls to check all resources for proper tag allocation. Schedule an AWS Lambda function through Amazon CloudWatch to periodically run the code. Now let's look into the correct option. And the correct option is A, use AWS config rules to define and detect resources that are not properly tagged. Now let's look into the next question, question number 32. A development team needs to host a website that will be accessed by other teams. The website contents consist of HTML, CSS, client-side JavaScript, and images. Which method is the most cost-effective for hosting the website? And the options are: A, containerize the website and host it in AWS Fargate. B, create an Amazon S3 bucket and host the website there. C, deploy a web server on an Amazon EC2 instance to host the website. D, configure an application load balancer with an AWS Lambda target that uses the express.js framework. And the correct option is B, create an Amazon S3 bucket and host the website over there. Look into next question, question number 33, which states a company runs an online marketplace web application on AWS. The application serves hundreds of thousands of users during peak hours. The company needs a scalable, near real time solution to share the details of millions of financial transactions with several other internal applications. Transactions also need to be processed to remove sensitive data before being stored in a document database for low latency retrieval. What should a solutions architect recommend to meet these requirements? And the options are: A, store the transaction data into Amazon DynamoDB, set up a rule in DynamoDB to remove sensitive data from every transaction upon write, use DynamoDB streams to share the transactions data with other applications. Option B, stream the transactions data into Amazon Kinesis Data Firehouse to store data in Amazon DynamoDB and Amazon S3. Use AWS Lambda integration with Kinesis Data Firehouse to remove sensitive data. Other applications can consume the data stored in Amazon S3. Option C, stream the transactions data into Amazon Kinesis data streams. Use AWS Lambda integration to remove sensitive data from every transaction and then store the transactions data in Amazon DynamoDB. Other applications can consume the transactions data off the Kinesis data stream. Then comes option D, which says store the batch transactions data in Amazon S3 as files. Use AWS Lambda to process every file and remove sensitive data before updating the files in Amazon S3. The Lambda function then stores the data in Amazon DynamoDB. Other applications can consume transaction files stored in Amazon S3. And the correct option is C, stream the transactions data into Amazon Kinesis data streams. Use AWS Lambda integration to remove sensitive data from every transaction and then store the transactions data into Amazon DynamoDB. Other applications can consume the transactions data of the Kinesis data stream. Now let's look into the next question, question number 34. A company hosts its multi-tier application on AWS. For compliance, governance, auditing, and security, the company must track configuration changes on its AWS resources and record a file of API calls made to these resources. What should a solution architect do to meet these requirements? And the options are A. Use AWS Cloud Trail to track configuration changes and AWS Config to record API calls. Option B. Use AWS Config to track configuration changes and AWS Cloud Trail to record API calls. Option C. Use AWS Config to track configuration changes and Amazon CloudWatch to record API calls. Option D. Use Cloud Trail to track configuration changes and Amazon CloudWatch to record API calls. And the correct option is option B, which says use AWS Config to track configuration changes and AWS Cloud Trail to record API calls. Now let's look into the next question. Question number 35. A company is preparing to launch a public facing web application in the AWS cloud. The architecture consists of Amazon EC2 instances within a VPC behind an elastic load balancer. A third party service is used for the DNS. The company's solution architect must recommend a solution to detect and protect against large scale DDoS attacks. Which solution meets these requirements? Option A, enable Amazon Guard Duty on the account. Option B, enable Amazon Inspector on the EC2 instances. Option C, enable AWS Shield and assign Amazon Route 53 to it. Option D, enable AWS Shield Advanced and assign the ELB to it. And the correct option is option D, enable AWS Shield Advanced. So basically, AWS Shield is used to protect your application from DDoS attacks and assign the ELB to it. And then you assign the elastic load balancer to it. Now, question number 36, it says a company is building an application in the AWS cloud. The application will store data in Amazon S3 buckets in two AWS regions. The company must use an AWS key management service, customer managed key, to encrypt all data that is stored in the S3 buckets. The data is in both S3 buckets must be encrypted and decrypted with the same KMS key. The data and the key must be stored in each of the two regions. Which solution will meet these requirements with the least operational overhead? And the options are A. Create an S3 bucket in each region. Configure the S3 buckets to use server-side encryption with Amazon S3 managed encryption keys. Configure replication between the S3 buckets. Option B. Create a customer managed multi-region KMS key. Create an S3 bucket in each region. Configure replication between the S3 buckets. Configure the application to use KMS key with client-side encryption. Option C. Create a customer managed KMS key and an S3 bucket in each region. Configure the S3 buckets to use server-side encryption with Amazon S3 managed encryption keys. Configure replication between the S3 buckets. Then option D, create a customer managed KMS key and an S3 bucket in each region. Configure the S3 buckets to use server-side encryption with AWS KMS, SSC KMS. Configure replication between the S3 buckets. And the correct option is option B, which says create a customer managed multi-region KMS key, create an S3 bucket in each region, configure replication between the S3 buckets, configure the application to use the KMS key with the client-side encryption. Now let's look into question number 37. A company recently launched a variety of new workloads on Amazon EC2 instances in its AWS account. The company needs to create a strategy to access and administer the instances remotely and securely. The company needs to implement a repeatable process that works with native AWS services and follows the AWS well architected framework. Which solution will meet these requirements with the least operational overhead? And the options are A. Use the EC2 serial console to directly access the terminal interface of each instance for administration. Option B. Attach the appropriate IAM role to each existing instance and new instance. Use AWS Systems Manager Session Manager to establish a remote SSH session. Option C. Create an administrative SSH key pair. Load the public key into each EC2 instance. Deploy a Bastion host in a public subnet to provide a tunnel for the administration of each instance. Option D. Establish an AWS site to site VPN connection. Instruct administrators to use their local on premises machines to connect directly to the instances by using SSH keys across the VPN tunnel. And the correct option over here is option B, which says attach the appropriate IAM role to each existing instance and new instance. Use AWS Systems Manager Session Manager to establish a remote SSH session. Let's look into question number 38. Company is hosting a static website on Amazon S3 and is using Amazon Route 53 for DNS. The website is experiencing increased demand from around the world. The company must decrease latency for users who access the website. Which solution meets these requirements most cost effectively? So the options are: A, replicate the S3 bucket that contains the website to all AWS regions, add Route 53 geolocation routing entries. Option B, provision accelerators in AWS Global Accelerator. Associate the supplied IP addresses with the S3 bucket. Edit the Route 53 entries to point to the IP addresses of the accelerators. Option C, add an Amazon CloudFront distribution in front of the S3 bucket. Edit the Route 53 entries to point to the CloudFront distribution. Option D, enable S3 transfer acceleration on the bucket. Edit the Route 53 entries to point to the new endpoint. Now let's look into the solution. And the correct answer is C. Add an Amazon CloudFront distribution in front of the S3 bucket. Edit the Route 53 entries to point to the CloudFront distribution. Now let's look into the next question, question number 39. A company maintains a searchable repository of items on its website. The data is stored in an Amazon RDS for MySQL database table that contains more than 10 million rows. The database has 2 TB of general purpose SSD storage. There are millions of updates against this data every day through the company's website. The company has noticed that some insert operations are taking 10 seconds or longer. The company has determined that the database storage performance is the problem. Which solution addresses this performance issue? And the options are: A, change the storage type to provisioned IOPS SSD. Option B, change the DB instances to a memory optimized instance class. Option C, change the DB instance to a burstable performance instance class. Option D, enable multi AZ RDS read replicas with MySQL native asynchronous replication. And the correct answer is A, change the storage type to provision IOPS SSD. Now let's look into question number 40. It says a company has thousands of edge devices that collectively generate 1 TB of status alerts every day. Each alert is approximately 2 KB in size. A solution architect needs to implement a solution to ingest and store the alerts for future analysis. The company wants a highly available solution. However, the company needs to minimize cost and does not want to manage additional infrastructure. Additionally, the company wants to keep 14 days of data available for immediate analysis and archive any data older than 14 days. What is the most operationally efficient solution that meets these requirements? And the options are: A, create an Amazon Kinesis data firehouse delivery stream to ingest the alerts. Configure the Kinesis data firehouse stream to deliver the alerts to an Amazon S3 bucket. Set up an S3 lifecycle configuration to transition data to Amazon S3 Glacier after 14 days. Option B, launch Amazon EC2 instances across two availability zones and place them behind an elastic load balancer to ingest the alerts. Create a script on the EC2 instances that will store the alerts in an Amazon S3 bucket. Set up an S3 lifecycle configuration to transition data to Amazon S3 Glacier after 14 days. Then option C, create an Amazon Kinesis data firehouse delivery stream to ingest the alerts. Configure the Kinesis data firehouse stream to deliver the alerts to an Amazon open source service cluster. Set up the Amazon open source service cluster to take manual snapshots every day and delete data from the cluster that is older than 14 days. Then option D, create an Amazon SQS standard queue to ingest the alerts and set the messages retention period to 14 days. Configure consumers to poll the SQS queue. Check the age of the message and analyze the message data as needed. If the message is 14 days old, the consumer should copy the message to an Amazon S3 bucket and delete the message from the SQS queue. And the correct answer is option A, which says create an Amazon Kinesis data firehouse delivery stream to ingest the alerts. Configure the Kinesis data firehouse stream to deliver the alerts to an Amazon S3 bucket. Set up an S3 lifecycle configuration to transition data to Amazon S3 Glacier after 14 days. Now let's look into question number 41. A company's application integrate with multiple software as a service sources for data collection. The company runs Amazon EC2 instances to receive the data and to upload the data to an Amazon S3 bucket for analysis. The same EC2 instance that receives and uploads the data also sends a notification to the user when an upload is complete. The company has noticed slow application performance and wants to improve the performance as much as possible. Which solution will meet these requirements with the least operational overhead? And the options are: A, create an auto scaling group so that EC2 instances can scale out. Configure an S3 event notification to send events to an Amazon Simple Notification Service topic when the upload to the S3 bucket is complete. Option B, create an Amazon App flow to transfer data between each SaaS source and the S3 bucket. Configure an S3 event notification to send events to an Amazon simple notification service topic when the upload to the S3 bucket is complete. And the option C is create an Amazon event bridge. Amazon CloudWatch events rule for each SaaS source to send out in output data. Configure the S3 bucket as the rules target. Create a second event bridge. Rule to send events when the upload to S3 bucket is complete. Configure an SNS topic as the second rules target. Option D, create a Docker container to use instead of an EC2 instance. Host the containerized application on Amazon ECS Elastic Container Service. Configure Amazon CloudWatch container insights to send events to an Amazon Simple Notification Service topic when the upload to the S3 bucket is complete. And the correct option is option B, which says create an Amazon App flow to transfer data between each SaaS source and the S3 bucket. Configure an S3 event notification to send notification to an Amazon Simple Notification Service topic when the upload to the S3 bucket is complete. Now let's look into the next question, question number 42. A company runs a highly available image processing application on Amazon EC2 instances in a single VPC. The EC2 instances run inside several subnets across multiple availability zones. The EC2 instances do not communicate with each other. However, the EC2 instances download images from Amazon S3 and upload images to S3 through a single NAT gateway. The company is concerned about data transfer charges. What is the most cost effective way for the company to avoid regional data transfer charges? And the options are: A, launch the NAT gateway in each availability zone. B, replace the NAT gateway with a NAT instance. C, deploy a gateway VPC endpoint for Amazon S3. D, provision an EC2 dedicated host to run the EC2 instances. And the correct option is C, deploy a gateway VPC endpoint for Amazon S3. Now let's look into the next question, which is question number 43. It says a company has an on premise application that generates a large amount of time sensitive data that is backed up on Amazon S3. The application has grown and there are several user complaints about internet bandwidth limitations. A solutions architect need to design a long-term solution that allows for both timely backups to Amazon S3 and with minimal impact on internet connectivity for internal users. Which solution meets these requirements? And the options are: A, establish AWS VPN connections and proxy all traffic through a VPC gateway endpoint. Option B, establish a new AWS Direct Connect connection and direct backup traffic through this new connection. Option C, order daily AWS Snowball devices. Load the data onto Snowball devices and return the devices to AWS each day. Submit a support ticket through the AWS Management Console. Request the removal of S3 service from the account. And the correct option is B, establish a new AWS Direct Connect connection and direct backup traffic through this new connection. Now let's look into the next question, question number 44. A company has an Amazon S3 bucket that contains critical data. The company must protect the data from accidental deletion. Which combination of steps should a solution architect take to meet these requirement? So basically the company wants to protect its data from the accidental deletion, and that critical data is stored on Amazon S3 bucket. So the options are: A, enable versioning on the S3 bucket. B, enable MFA delete on the S3 bucket. C, create a bucket policy on the S3 bucket. D, enable default encryption on the S3 bucket. E, create a lifecycle policy for the objects in the S3 bucket. And the correct option is AB, which is enable versioning on the S3 bucket, and B, enable multi-factor authentication delete on the S3 bucket, MFA delete on the S3 bucket. Now let's look into question number 45. A company has a data ingestion workflow that consists of the following: an SNS topic for notification about new data deliveries, an AWS Lambda function to process the data and record metadata. The company observes that the ingestion flow workflow fails occasionally because of network connectivity issues. When such a failure occurs, the Lambda function does not ingest the corresponding data unless the company manually reruns the job. Which combination of actions should a solution architect take to ensure that the Lambda function ingests all data in the future? And the options are, you have to choose the two options. A, deploy the Lambda function in multiple availability zones. B, create an Amazon simple queue service queue and subscribe to it to the SNS topic. C, increase the CPU and memory that are allocated to the Lambda function. D, increase provision throughput for the Lambda function. E, modify the Lambda function to read from an Amazon SQS queue. And the correct option is B and E, which is create an SQS queue and subscribe it to SNS topic. And E is modify the Lambda function to read from an Amazon SQS queue. Now let's look into question number 46. And a company has an application that provides marketing services to stores. The services are based on previous purchases by store customers. The store uploads transaction data to the company through SFTP, and the data is processed and analyzed to generate new marketing offers. Some of the files are can exceed 200 GB in size. Recently, the company discovered that some of the stores have uploaded files that contain personally identifiable information that should not be included. The company wants administrator to be alerted if PII is shared again. The company also wants to automate remediation. What solution a company should know? I mean, what solution should a solution architect propose to meet these requirements with the least development effort? And these are your options. Option B is the correct option, which says use an Amazon S3 bucket as a secure transfer point. Use Amazon Mackie to scan the objects in the bucket. If objects contain PII, use Amazon SNS to trigger a notification to the administrators to remove the objects that contain PII. Now let's look into the next question, question number 47. A company needs guaranteed Amazon EC2 capacity in three specific availability zones in a specific AWS region for an upcoming event that will last 1 week. What should a company do to guarantee the EC2 capacity? And the options are A, purchase reserved instances that specify the region needed. B, create an on demand capacity reservation that specifies the region needed. C, purchase reserved instances that specify the region and the three availability zones needed. D, create an on demand capacity reservation that specifies the region and three availability zones needed. And the correct option is D, create an on demand capacity reservation that specifies the region and three availability zones needed. Now let's look into the next question, question number 48. A company's website uses an Amazon EC2 instance store for its catalog of items. The company wants to make sure that the catalog is highly available and that the catalog is stored in a durable location. What should a solutions architect do to meet these requirements? And the options are A, move the catalog to Amazon Elastic Cache for Redis. B, deploy a larger EC2 instance with a larger instance store. C, move the catalog from instance store to Amazon S3 Glacier Deep Archive. D, move the catalog to an Amazon Elastic file system. The correct option is D, move the catalog to an Amazon EFS file system. Now let's look into question number 49. A company stores call transcript files on a monthly basis. Users access the file randomly within 1 year of call, but users access the files infrequently after 1 year. The company wants to optimize its solution by giving users the ability to query and retrieve files that are less than 1 year old as quickly as possible. A delay in retrieving older files is acceptable. Which solution will meet these requirements most cost effectively? So basically, they want us to choose one of the solution which will meet this requirement cost effectively. And the options are A, store individual files with tags in Amazon S3 Glacier Instant Retrieval. Query the tags to retrieve the files from S3 Glacier Instant Retrieval. Option B, store individual files in Amazon S3 Intelligent Tiering. Use S3 lifecycle policies to move the files to S3 Glacier Flexible Retrieval after 1 year. Query and retrieve the files that are in Amazon S3 by using Amazon Athena. Query and retrieve the files that are in S3 Glacier by using S3 Glacier Select. Option C, store individual files with tags in Amazon S3 standard storage. Store Search metadata for each archive in Amazon S3 standard storage. Use S3 lifecycle policies to move the files to S3 Glacier instant retrieval after 1 year. Query and retrieve the files by searching for metadata from Amazon S3. Option D, store individual files in Amazon S3 standard storage. Use S3 lifecycle policies to move the files to S3 Glacier Deep Archive after 1 year. Store search metadata in Amazon RDS. Query the files from Amazon RDS. Retrieve the files from S3 Glacier Deep Archive. And the correct option is B, that is store the files individual files in Amazon S3 intelligent tiering. Use S3 lifecycle policies to move the files to S3 Glacier Flexible Retrieval after 1 year. Query and retrieve the files that are in Amazon S3 by using Amazon Athena. Query and retrieve the files that are in S3 Glacier by using S3 Glacier Select. Let's look into question number 50. A company has a production workload that runs on Amazon 1000 Amazon EC2 Linux instances. The workload is powered by a third party software. The company needs to patch the third party software on all EC2 instances as quickly as possible to remediate a critical security vulnerability. What should a solution architect do to meet these requirements? And the options are A. Create an AWS Lambda function to apply the patch to all EC2 instances. B. Configure the AWS Systems Manager Patch Manager to apply the patch to all EC2 instances. C. Schedule a AWS System Manager maintenance window to apply the patch to all EC2 instances. And D is use AWS Systems Manager run command to run a custom command that applies the patch to all EC2 instances. And the correct option is D. So that's it for today. I hope you enjoyed the video, and it contains a lot of informative information about the Solution Architect Associate exam. And please go through all the questions so that you can practice it and you can do well in your exam. All the best for exam. Please consider subscribing to our channel. Thank you for watching. Bye bye.